Gossip with ShopSabre CNC. Around here they call me RouterBob. We have a very interesting video for you. You know, we get a lot of requests about a software called Fusion 360 that's actually created by Autodesk. It's full parametric solid modeling, and it actually has a full CAM package, so you generate toolpaths with it. And something that's really neat about it, it runs natively in the Mac operating system as well as Windows. So we're really excited about that. Now, we decided the way to do that software was to select a product and build everything within that software. And our product is going to be a lumber storage rack. And you use it with your CNC router so that as you unload parts off the table, they get sorted automatically. Now, before we do that, let's take a look at the machine that we're actually going to be cutting that storage rack on. The machine we're using today is the ShopSabre Pro Series. This happens to be a 4x8, and it's absolutely one of my favorite machines to run. You know, people ask me all the time, how do you judge a machine tool? I said, well, it's really not that hard. I start at the base, because if you don't have a good base frame, nothing else you put on there matters. We use structural steel. It's an all-welded one-piece base, and that's really why you get such good edge finishes and such good accuracy. Now, the other part of the frame is actually the gantry itself, and we use a structural steel gantry also. And that's actually supported on the frame with these supports, and they're structural steel. So that's the most important components to creating a quality machine tool CNC router. Now, let's look at motion. You know, the next area I look at when I evaluate a CNC machine tool is actually the motion system, what makes it move. What we do at ShopSabre CNC is we start with precision ground contour guide rails. Those actually create the axis of movements, and then we actually use precision ball screws to create that movement. Now, let's talk about that a little bit. Sometimes we get a question, you know, are ball screws better than rack and pinion? Well, the answer is yes. They're more accurate, they don't have play in them. Now, one thing that's really funny, some people who only have rack and pinions will try to tell you how they're good if they use ball screws on the most accurate axis, the Z-axis, because it controls depth. We use ball screws because our design criteria is to create a machine tool grade CNC router, therefore we have to use ball screws. Now, what actually makes the ball screws move are motors, and we use closed loop servos, and they're Mitsubishi. So the Mitsubishi motors and drives are matched for this entire system. Now, the final component of motion control is the machine control itself, and let's go take a look at that. Okay, we developed the ShopSabre MMP controller based on some real rock solid control technology from Mitsubishi. And we did that because we wanted the reliability that Mitsubishi is known for. But there's another part of machine control that you have to consider, and that is the people part, or the user interface part. And our goal was to create something that was real easy to use and easy to learn, that a typical worker could master, that I didn't have to have someone with a technical or engineering background. And so one of our first goals was to accomplish that, so we put all the controls on a single screen. So everything the operator needs to run a machine control is right there. Now, that screen is actually running in a Windows computer. And we did that for a couple of reasons. One is that allows us to network to the company network, and that lets us transfer files from the front office. So that was one reason. The other reason is nowadays it's real popular to actually run software on the machine control itself, and the Windows part of the system allows us to do that. So that worked out really, really well. Let me show you how you actually use this controller. All right, the first thing I do is I load a program. All right, it comes up, and then there's a little eye over here that I can click, and it actually draws the program. So over here on the graphic part of the screen, you can actually see what you're going to cut. So that's visual validation that you've loaded the correct program. All the buttons that you need to move it around are there. You simply hit cycle start, and everything works. So it's really created a great system so that you know, a typical operator can be successful. Now, let's take a look at actually how we cut. So let's look at the router spindle itself now. This machine actually has an HSD ATC spindle. ATC means automatic tool changer. This machine is actually equipped with a 5-position automatic tool changer. And we make these in a number of different horsepower selections depending on what your application is. Now, one of the things I always like to point out when we talk about these spindles, I moved the dust hose out of the way so that we could see it better. These stiffener plates. Now, there's an interesting story that goes with those. What we wanted to do was to get the maximum edge finish that we possibly could. And so we realized if you could extend that tool plate down, or the stiffness of it, it would be better. All right, so here's how we started this. We opened up the finite element analysis software, and that's engineering design software that we use to design everything at ShopSabre. All right, and so we said, okay, what our challenge is to increase that stiffness. So we plugged some different scenarios into the software, and one popped up that it looked really, really good. So we made the parts, we actually tested the machine, and it tested out really well, so we knew we were onto something. Then we stepped back and we said, okay, can we achieve the same result and reduce mass? And that's why you see these cutouts on both sides, and it worked out really, really well. So it created a much, much better spindle mount, and that's why these machines are accurate, and that's why the edge finishes are so good. Now let's carry this further. One of the things you also see on these machines is we have axis travel that's higher than the gantry. So there's 12 inches under the gantry here of clearance, but I actually have 16 inches of travel. So I can actually machine on top of a piece if it fits under the gantry. A lot of machines don't do that. Now there's another thing, as you look up to the ball screw, you see a part called a balancing cylinder. Now here's what that does. First off, you have a ball screw drive, all right? All of this is mass, and because of gravity, it's weight. So what we have to do is we have to raise and lower all that mass. Well, it's real easy to lower it because gravity is your friend, but gravity is your enemy going the other way. So what we created was a balancing system to take that weight off. So there's no more pressure going up or down on the ball screw. Now here's what that does. First off, it makes the ball screw last a lot longer, but there's another part of machining that people don't understand, and that's when you get into 3D machining. 3D machining is cutting the surface and you're doing a lot of up and down and Z. Well, the speed is actually determined by the slowest axis. So you can have really rapid X and Y moves, but if you're real slow on the ball screw, your 3D machining is slow. So this whole system, using a balancing cylinder, enables us to really, really do 3D fast. So that was a tremendous benefit of our design project on this, and it worked out really, really well. Now, there's one other part of the machine that we haven't talked about, and that's the machine table, and let's take a look at that. Now let's take a look at the table on this machine. This is a vacuum table. The material is actually phenolic. We also offer other table options. One is a special treated MDF that's very, very popular, as well as an aluminum table. Now, what's funny is I look at the label and it says 408, and so I think, well, that must be a 4-foot wide machine. But when I put a tape measure on there, I get a little bit of a surprise. When I measure the table, it's 5 feet wide. And since we machine the table on the machine with the router, I know I have full table coverage. Well, the benefit of that is that I can take a 4x8 machine and cut those 5-foot by 5-foot pieces of Baltic birch that you make drawers out of so often. So I don't have to buy a larger machine just to do that. Now, typically these machines would be used on nested base manufacturing. And you use a technology called flow through. And basically we pull vacuum through an MDF panel, and that holds the parts. And the design of the vacuum system is really, really important, or the small parts move around on you. Let me tell you how we did it. If you notice, we start out with 8 vacuum ports, and they're large. Okay, they're rigid tube. We don't use flexible hoses because you lose some vacuum flow because of the interior of that. Those actually then feed into a vacuum plenum that's actually a frame member in the machine base frame itself. All right, we have 4 valves that control the zones, and then the plenum itself is connected to the back of the machine with a large 4-inch pipe. So you get tremendous flow on this design, and where that helps you is when you're doing nested base stuff, the small parts don't move as bad. So it's a really, really nice design, and it's been very well thought out of. Okay, now we've looked at the machine. Let's go look at the software portion of this demonstration.
At ShopSabre CNC, we try to stay on top of software trends. And after you do this a while, you have certain softwares that you like, and people are able to be successful. But something that's come up a lot lately is a product from Autodesk called Fusion 360. And so we decided that we would actually use Fusion 360 as our platform for one of our demonstration videos. So that's how that got started. Now, one of the reasons that really attracted us was it actually can run in the Mac platform natively. It's available for the Mac and for Windows. And so it really made a lot of sense because there's not a lot of programs that you can run natively in the Mac that'll generate code for these machines. So we thought that makes a lot of sense. All right, now let's take a look at what we're actually making here. This is a storage rack. And what happens is when you're doing nesting, so you're putting a sheet of material on the table and you're cutting out all these parts, sometimes you have parts from more than one cabinet on that sheet. And if you're not careful, you get them all mixed up, and then it takes longer to sort them out than it does to machine them. One of the most clever systems I've ever seen is this storage rack system. Now, typically the machine operator is going to get, they're going to have a layout of what's on the machine. And so as they take parts off, they say, okay, this part goes in cabinet 1, then I put it in slot 1, and so forth over here. So you have maybe 3 or 4 of those racks. You have to accommodate the number of cabinets. And when you're finished, all your parts are sorted. So it works out really nice. And we even pre-drill this so that you can put casters on it, you can move those around. So that's the product I wanted to make because I thought it made a lot of sense when you're doing nesting. And I also want to show you this software. So here's basically, I'll show you what the parts are. This is actually a rendering that we've rendered it, but there's one of the parts. So these are called partitions. So there's 5 of those. And then there's a bottom here, or I call it a shelf actually, and there should be one right here. And those slide in and they join in the middle. And then as we look down below here, there's actually a bottom, and then there's some rails that go around it. So it basically all fits together and it screws together from the bottom. So that's what we wanted to start with. So that's the final version. Now let's step back a little bit and let's talk about what this software really is. Okay, let's go back to the modeling tab. Okay, now these are, once again, these are the parts. And all right, here's what this software is. You start with a drawing. You start with a flat 2D drawing of a part, and then you create a model out of it. So you basically extrude thickness and it creates a model. And then you can put the other features like holes and stuff. So that becomes a model, or what they call a body. Then that body then is converted into what's called a component. Then components can actually be assembled. So they form assembly. So technically this is an assembly that you see on the screen. So that's the whole idea, is to be able to go all the way from the drawing design all the way to the assemble. Now, and they're parametric. Now here's what parametric means. If I change something on one of those parts, everything else gets changed that has that part. Any instance that part's used, that change is made. So that's the parametric part. So it's really, really powerful. And you can actually do animation, so you can have things move around and come back together. What we're really interested here, though, is to actually make this cart. And I'll switch some of these parts on. Everything's pretty much controlled over here. I can turn the bottom. Here's the bottom. I'll turn that where that's not visible. There's the shelves. There's the partitions. Turn the shelf off. You see how all that fits together? So those pieces fit down in those grooves. So it's unbelievably powerful. Okay, now, so that kind of covers the basic design part. Now, let's talk a little bit about the manufacturing part. How do I go from this to something on the machine tool? Okay, once we get the design completed, now we're ready to shift to the manufacturing part. Well, how am I going to make this on a CNC router? Well, I'm going to lay those parts out onto a nest, a sheet of material. The machine's going to cut them out, hopefully. So let's turn another view on here. There's actually what the nest look like. Now we'll look a little closer here, and you can kind of see these are, I call these parts partitions. There's 4 of them on there. Now what you're seeing right here, that board underneath, that's actually the spoil board. So that's an MDF spoil board. And I really put that on there to give you a little bit of perspective of where things are, and also to set the origin so that the machine locates these correctly on the table. So there's one nest, and then of course we've got the second nest. And you notice the sizes of those work out where you use a 4x8 sheet of material, or 2 of them, pretty well. So you really get good material utilization on that. And of course, these are what I call the shelves, and these are the rails, and this is the bottom, and this is the 5th partition. Okay, so that's basically how I want to attack manufacturing on this. I want to throw 2 sheets of material on the machine. I want to cut the parts out. Okay, so now let's switch over and let's talk about the CAM part, or the tool pathing part of the process. Okay, now let's focus on the actual manufacturing, how we apply the tool paths. Well, the way you do that in Fusion 360 is you go to this tab where it says CAM. CAM stands for Computer Aided Manufacturing, if you don't know that. All right, now the first thing we actually have to do is is basically tell the software where we want the origin to be, because that corresponds to how it operates at the machine. So what I've done here, now remember this MDF is actually the spoil board. Now the transparent area here is actually the sheet of material. And you see where we've set the origin. There's XYZ. It's at the corner of the spoil board, just like we would do cabinet parts. Okay, so that's pretty good. Now, this only takes one tool on here because all we're doing is cutting these parts out. So that's what you see right here. You see where it starts, and if you watch, I ramped in just like we normally would. With nesting, I started in the middle of an edge. I ramped in so we'd get a real nice entry on there. All right. Now, one of the things that Fusion 360 has, it has real good simulation. So let's click on simulation. I'm going to say show the stock, and I want the stock to be ceramic. The reason I chose ceramic is because it looks pretty good on here, to tell you the truth. I'm going to make it transparent. All right. Now, to simulate it, all I do is click the play button, and here, what you see here is what's going to happen on the machine. It's almost that fast. It's not quite, but it's pretty fast when you watch it on the machine. And that's about on the machine, it's a 3 or 4 minute program. All right, so that's the first part. And so then we would output the machine code and send that out to the machine by the network, and then we would run that, all right? So that came out pretty good. Now let's back away from here. Now let's look at this one. All right, we're going to do the same thing. Here's the nest. Here's our origin. Once again, that's what makes this connect to the machine and position the parts correctly. That's why I can have multiple sheets out on the table, because I can say, okay, this is where the origin is going to be whenever you generate code. All right, let's run. Now this one's got more tool paths. Let's take a look at those. First off, what I'm going to do is I'm going to drill some holes here. All right, now the reason I want to do that is those are pre-drill pilot holes for the screws, so when we screw it together, it's just easier. Okay, these are actually bores here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and those are for bolt holes to bolt casters on. So we basically want the machine to do that, and in this case, we're not drilling, we're actually machining the holes. So we'll actually have a spiral tool path that goes down through there. All right, and then this one is a pocket. These are pockets, so this cuts pockets out for the partitions to fit in. Okay, now this one's interesting here. This is an onion skin pass, and here's why I did that. First off, these parts right here probably fall into what you might call small parts, and small parts with flow through have a tendency to want to move. And a small part can be a small area, or it can be narrow. So I felt like, well, those are narrow enough, they might do that. Okay, so what we do first is we cut through those and we leave 30 thousandths. That's called the onion skin. And I went ahead and decided to do these larger parts the same way, because sometimes these little narrow pieces here would vibrate, so it's just to be safe. So the first thing that happens then is those get cut out, so these 4. Okay, then we come back, and what this does, it looks the same. The only difference is now we're cutting through the material 10 thousandths, so those parts are separate. And then finally we do the same thing to the large parts. All right, so now let's actually start up here and let's go to simulation. Let's see what it looks like. Okay, let's get our stock on there. And it's transparent, that looks pretty good. We'll get this out of the way. We'll hit the play button, and here's what's going to happen. So there's your drilling. So those are the pilot holes for the screws. Okay, then we're actually boring or machining those holes to mount the casters. Now we're cutting the dado. And then finally it'll move over and it'll start cutting the parts out. Okay, there's that first pass, so that's the onion skin pass. So the reason that works so well is because when we cut through the onion skin, the cutting pressure is so light, it really doesn't mess with it. Sometimes if you're cutting through a piece full thickness, sometimes on small parts there's a tendency for them to want to move, but the onion skin pretty much takes care of that. So that's why we did that. You might not have to, but we know that works. All right, and then once we're doing the second pass on those. So now those are actually cut free. We're actually cutting through about 0.010 of an inch. We don't want to cut too deep because we don't want to mess up our spoil board. Okay, now we're going to do the pass on the outside for the large parts. Now, both those programs together took a little less than 15 minutes. So in 15 minutes on the machine, I have all the parts I need to assemble that cart. So that's how that's done. Now the final step we have then on this is actually just to generate the program files, send them out on a machine, and run them. Let's go out the machine and do that.
Okay, we've got all the parts cut for our storage rack. I'm going to take a look at one of these. You know, it just amazes me how good the finish is on here. And you know, this is really dense material. This is Baltic birch. You know, something I noticed too is this part, because it was smaller, actually had an onion skin pass. But you know, you can't tell it. A lot of machines, you can actually tell that when you look real close. That just tells you how good the frames are on these Pro Series. Okay, now, the other thing about this, both sheets together took about 15 minutes to machine. So in 15 minutes of machine time, we were able to actually produce a storage card. Now, I think I'm going to turn these parts over to the ShopSabre cabinet assembly team. They're going to put them together and mount the casters, and then we'll take a look at the results. See you in a minute. Well, our assembly team has delivered the storage rack, and it came out really nice. Everything fit exactly as we designed it. You know, one of our goals on this project was to actually take a new software, Fusion 360, do the entire design and development and the outputting toolpaths. And it came out really good. I'm tremendously impressed with how well that software worked for us. Now, if you have any other questions, you can contact us at shopsabre.com. Thank you for watching.